Alright, so in the last video we introduced the Pythagorean Theorem and we were finding the hypotenuse. In this video we're going to be talking about finding one of the legs. So we'll be given the hypotenuse and we need to find one of the other sides. So we're going to use the Pythagorean Theorem to also find the length of a leg when we know the hypotenuse and the length of the other leg. Ooh, that's an interesting looking G. Let's try that one again. Other leg. We're going to use that. Use, a squared plus b squared equals c squared. So again, c is always across from the right angle. That is always our hypotenuse. So in this time, we're going to be given c and a, or one of these side lengths, and we're going to look for b. Or at least I always just say I'm looking for b. And so we can think of it as plugging into a squared plus b squared equals c squared, and then solving, which we'll do most of our examples using, or knowing what I know about equations, to get b squared by itself, I can subtract a squared from both sides. And it is the same to do b squared equals c squared minus a squared, and I will be able to find b that way. And so we'll do a couple examples using both methods, either starting a squared plus b squared equals c squared and solving, or starting directly with b squared equals c squared minus a squared. So we'll see how both of these, or you'll get to see how both versions work. It gives you the same answer either way, which is why both versions work. All right, so we want to find the unknown leg. Here's my right angle. I go across. I decide, oh, I know my hypotenuse C. And since I know C, then I am given A, and I am looking for B. And so using a squared plus b squared equals c squared, our Pythagorean theorem, A is 12, so we're going to have 12 squared plus we don't know b squared equals c, which is 13 squared. And so then 12 squared is 144 plus b squared, because we're going to simplify our squares first, equals 13 squared is 169. From here, we want to get b by itself. So to get b by itself, I have to start by subtracting 144 from both sides. So then b squared would equal 169 minus 144 is 25. And then our last step, because I want b, not just b squared, I'm going to square root both sides. And so then b will equal 5, because that's the square root of 25. So again, walking us through, here's the right angle. Across from the right angle is my hypotenuse. I plug into the Pythagorean theorem, so I plugged 12 in for a. b I do not know, so it stayed b squared equals c, which is 13, so equals 13 squared. I simplify the squares, so 12 squared is 144, 13 squared is 169. That's how I get this line here. From there, I use the the subtraction property of equality to subtract 144 from both sides. And then I square root both sides to get b by itself, which means that b equals 5. So it's like what we were doing before, it's just we've got to isolate our variable on one side. So this is one way of doing it. We want to know the length of the unknown leg. So here is my right angle. I draw an arrow across from it. That means I'm given the side length C. So this one I'm going to call A, and our unknown we're going to call B. On this one, I'm going to go back to what I was talking about here, and I'm going to use this version of the formula, b squared equals c squared minus a squared. Because when you think about it here, I took c squared, which was 13 squared, minus the 12 squared. So that's what we're going to start with here. B squared equals c squared minus a squared in order to find our missing side length. So then b squared will equal, c is 17.5, so 17.5 squared minus a, which is 10.5 squared. I'm going to square both, so b squared will stay. 17.5 becomes 306.25 minus 10.5 squared becomes 110.25. So then I'm going to take the 306.25 minus the 110.25, and I will get that b squared equals 196. And then the opposite of squaring something is to square root. So then b will equal 14 because the square root of 196 is 14. So we did the same thing, it's just I started off with a different form. So again, if we go back to the one before, here I have a squared plus b squared equals c squared. And after we evaluate, then I subtract over. Whereas on this one, I went ahead and subtracted the a squared over, at least moved it over to say it's going to be subtracted, evaluated the squares, and then did the subtraction. So either way you want to do it, I'm going to keep doing it from like the first one, but if you like the second method, go ahead and use this second method. Excuse me. And now we're going to do a couple of real life problems where Pythagorean Theorem comes into play. So all TV screens, when they tell you that it's a 42-inch TV, it's a 50-inch TV, it's a 64-inch TV, whatever it may be, that is the diagonal of the screen. So the length of the diagonal of a television screen, in this case, is 42 inches. And the length of the bottom of the screen is 36 inches. And to the nearest tenth, what is the height of the television? So we're wanting to find this side over here. Here's my right angle, so that means that the 42 is my hypotenuse. So that's C, which makes this B. And we're going to call this one A. So plugging into a squared plus b squared equals c squared, I'm going to get 36 squared plus b squared equals 42 squared. 36 squared is 1,296 plus b squared equals, and then 42 squared is 1,764. Now, to get b by itself, I'm going to subtract my a squared from both sides. And so then b squared will equal 468. To get b by itself, we'll take the square root of both sides. And so b will equal, the square root of 468 is 21.6. Because we're rounding to the nearest tenth. So anyway, sorry, I got distracted. 21.6 inches is our height for our television, which makes more sense than 468 inches, right? We're talking about a height of a television. 468 inches is a very, very tall anything, considering that 5 feet is only 60 inches. So anyway, that's how we solve it. Again, it's just substitution and then solving for your unknown. Last problem. The entrance to the Louvre Museum in Paris, France is a square pyramid. It's awesome. I've been there. It's really cool architecture and just pretty cool in general. We're going to find to the nearest tenth what is the height of the pyramid. So what I'm going to do is I'm going to pull and create my own triangle, right? Ooh. I thought I was going to create my own triangle. Let's try this one more time. There we go. That's a little bit closer to a right triangle. All right. I know that this slant height right here, which is going to be our hypotenuse, is 27.9. I know I want the height. So this is going to be my B, and that my, so this is C, and that my A. Now remember when we talked about this in our last section, because the height drops to the middle of the pyramid, I only want half of the 35.4. So half of 35.4 is 17.7. So again, that was 35.4 divided by 2 equals 17.7. From here, I'm going to use Pythagorean Theorem. So a squared plus b squared equals c squared, which means 17.7 squared plus b squared equals 27.9 squared. And now I'm going to square both of these numbers. 313.29 plus b squared is going to equal 778.41. And then to get b by itself, we're going to subtract 313.29. And so then b squared will equal 465.12. But I want the height. And right now this is b squared, so I've got to square root both sides because that is our last step. And so then b will equal the square root of 465.12 is 21.6, and then we are in meters. And so the height of the pyramid is 21.6 meters. So again, the only difference in this one is that we are finding a side other than the hypotenuse. But when you're doing your test, these problems will be intermixed, sections 2 and 3. So you really have got to be able to know, are you given 2 legs and are looking for the hypotenuse, or are you given the hypotenuse and a leg and looking for the other leg? And then that helps you set up your problem from there. Other than that, we're done until next time.